Hello guys, welcome to our module for week 11. So our topic for this week is about user-defined functions. User-defined functions are similar to those provided by SQL Server or MySQL as standard. They are given a name and optionally a set of parameters. They are created for a database and can be used in scripts, stored procedures, triggers, or other user-defined functions that are defined within the database. Like stored procedures, they help to modularize your code and improve maintainability by allowing you to centralize logic. For example, you could create a function that returns a standard tax rate. If the tax rules change, the function can be modified and all the SQL that utilizes the function would use the new tax rate automatically. User-defined functions can be separated into two main categories. They are the scalar functions and the table-valued functions. When we say scalar functions, they are similar to the functions that we have used in our earlier modules. They can optionally accept one or more parameters and they can only return a single value. Take note, scalar functions only return a single value. The return value is a standard data type but cannot be a text, and text, image, or timestamp. Table valued functions, on the other hand, returns a table variable. Table valued functions are often used as parameterized views as they can be included in place of tables in a query and can accept arguments. Such queries select from the rows provided in the function's result. Basically, table valued functions are functions that returns a table and behaves just like a table because we are using a table variable in table valued functions. Table valued functions can be further categorized into inline and multifunction variations. This determine the syntax used when creating the function but do not change the way in which it is called. Inline function contains a single statement, which must be a select statement. The result of the query becomes the return value of the function. Multifunction table valued function, on the other hand, can include many statements similar to a stored procedure. The table structure to be returned is defined within the function rather than being implicitly created to hold the query's result. Batch of statements is used to populate the table variable before it is returned. Now let us create a simple scalar function. The first function that we will create will be a simple scalar function that returns a tax rate. This could be used throughout the database when calculating the tax on sales. If the government changes the tax rate, it would require a single change to modify all of the functionality in the database that uses the percentage. As the rate is fixed, no parameters are required for this function. The syntax for creating a function with no parameters is as follows. For SQL Server, use the syntax create function and then the name of the function and then open close parenthesis. Inside the open close parenthesis are our variables together with their data type. So this is optional, okay? Meaning to say we can have a function without variables, followed by the keyword returns, and then what data type the function returns, followed by the keyword as, and then begin and end. Inside our begin and end statement, we will place our SQL code or SQL statement. And then lastly, we will provide the return keyword followed by the value that we will return. The signature of the function contains two key elements. The function name, which is a unique name for the function, and return type defines the data type that will be returned. The begin and end keywords can include multiple statements. The return value is the value that the function returns to its caller and must be of the type declared in the signature. So return data type must be the same as the return data type value. For MySQL, okay, for MySQL, the syntax is Okay, for our MySQL, the keyword is create function, followed by our parameters. Again, this is optional, followed by return keyword, type, or MySQL statements. Return keyword expression. If you notice, this is almost the same as that of the SQL Server, except that SQL Server uses the as before the begin and end state. So to create a simple tax rate function and set the value that it returns to 17.5, we execute the following code. To create function tax rate, returns numeric as begin return 17.5 and for MySQL, the keyword is the syntax is the same except that we remove the as keyword and we place a semicolon after the return state. Okay, so let us see the code in action. So for this lesson, we will be using bbfiddle.uk. It has a um better visual interface, and I think it's more stable than the compilers we were using before. Now for SQL Server, we will place our function here on our first code line. Okay, and then after compiling, code is successful. And then if we are to execute this in MySQL or in MariaDB, take note, this is the code and it compiled successfully. Now, how do we call our function? Now, for SQL Server, in order for you to call your function, you need to include the keyword DBO. DBO represents the schema name. Okay. So schema names are used to separate elements of the database and provide different schemas for different users. So if we want to say that we are using the default schema, we use the keyword DBO. Now, we have two means of displaying the output. You could use either print, which will display to our console, or better yet, just use select to display the particular value. For MySQL, it's almost the same. We use select. However, we do not include the DBO dot prefix here, so no need for that. So after executing, so for SQL Server, it will output 17.5. For MySQL, again, the same 17.5. Select. Modifying a function. To modify an existing function, you use the alter function command. The syntax for the command is identical to that of the create function. If, for example, we are to increase the tax rate from 17.5 to 18.75, so the code will be for SQL Server, alter function, function name, returns data type as begin, return, and end. However, for MySQL, you cannot use the alter function for function. You cannot use alter for our function. It will not work properly. Okay, so in order for us to circumvent this issue, first we drop the function. Then after dropping the function, you execute the create statement again. Okay, so let me show you. For SQL Server, we have alter function tax rate, then we change it to 1875. Once we execute it, if you select TBO.tax rate, it will display 1875. MySQL, we use drop function tax rate, create function tax rate. We execute this one. Then after doing that, we select tax rate, and then it now becomes 1870. Now, how do we use or add parameters? So simply, in order for us to add the parameter for our function. For SQL Server, we place the at symbol to signify that we are declaring a parameter, and then followed by the variable name, followed by the data type. So we can have one, two, or three or more parameters inside our function. So in this example, we are creating a function called value with tax, which returns the data type money. What it will do is to add the value that we have inserted to our parameters to the function tax rate divided by 100. Okay. For MySQL, it's almost the same. We just remove as, and then because MySQL doesn't have the data type money, we use the decimal data type, or you can use float data type or numeric data type if you want. But for in our example, I will use decimal. So it's the same syntax. Just take note, we do not use TBO prefix for MySQL. So once we execute this, what will happen? So for SQL Server, we have create function value with tax, then return. And then after executing TBO.value with tax 250, the output is 296,850. Okay, for MySQL, okay, the same. The output is the same. To demonstrate the new function, execute the following query. This accepts all the contracts from the database, showing the contract number, contract value, and the value with the tax rate added. So we'll create a table called contracts with contract number and contract value. So for this one, to work with SQL Server, again, we will use DBO prefix followed by uh, value with tax, and then the parameter will take the value on the column contract value. See. And for MySQL, it's the same. Just remove the prefix. So if we run it for SQL Server, okay, notice I have created a table here, okay, and then I run the code. So this will be the output for MySQL, the same, and this will be the output. Take note, guys, when you are using MySQL, the syntax for the tables, okay, the default configuration for the table name should be in small caps. Okay, so as much as possible, if you are declaring table names, you use small caps. Next, inline table valued function. Now, inline table valued functions are generally used to create parameterized view. They do not include statements in the begin and ending block. Instead, the body of the function is the actual select statement that may use the values passed in as arguments or parameters. The syntax is create function, function name, parameters, returns table as return, and then what is the query to be returned as your table. MySQL does not have an equivalent for this one, but you can use stored procedures instead. Okay, for this example, we will create a table called job list with columns job name and visit name. Okay, we will create a function called job list by job name, having one parameter called job name, which is bar chart. It returns table, and then as, then return. What will it return? It will return the values from job list where the job name is equals to our parameter at job. So once created, a table valued function can be used as the data source in a select statement. Only a select statement, guys. Again, only a select statement. You cannot do update, insert, delete from our inline table value function or our table value function. So in this example, we will find all data with electrical socket failure as the job name. Okay. Select asterisk from job list by job name. So this parameter will be used in our what? In our workload. In this example, okay, here, so successfully executed. So first example, electrical socket failure. So it will display all job name having electrical socket failure. But notice on our second example, we will display electrical socket failure, but we can still use a work loss because this is treated as a single table. Okay, so we can perform a work loss because this is stated as a table. So we will perform where visit date is equals to 2008 March 2. This is the result. Okay, creating a multi-statement table valued function. Multi-statement table-valued functions can be used to create very powerful functions that return table data. They include a set of statements contained between begin and end. The body can read information from the database and perform many other tasks you could include in stored procedures. When defining a multi-statement function, the return value is declared as a table variable and includes the full structure of the table that will be returned. The body of the function performs actions that fill the table variable with data. At the end of the processing, the return statement is used without a value and the previously declared table variable is returned. Okay, so in this example, guys, we will use a table, two tables, table trainer and table Pokemon. So we are going to count all Pokemon owned by a Pokemon trainer using the function fn or function underscore PokeCount. So this is only available for SQL Server. MySQL does not have an equivalent code for a multi-statement table value function. Only scalar functions are supported by MySQL. So this is our code. We will return a table data type called trainer data, which has an ID, trainer, and Pokemon count. So in our beginning declaration, we declare two variables, PokeCount and trainer ID, which are integer. And then we insert into our table variable trainer data all the trainers from our table trainer. Using a cursor, we select the ID from trainer data table variable. We open our cursor and then we fetch our data into the add trainer ID variable that we have declared earlier. And then using a while at fetch status loop, okay, we count all the Poke ID from table Pokemon where the trainer ID is equivalent to the value given to us by our cursor. After doing that, we update our table trainer data and then we set the Pokemon count to the count that we had received earlier. And then we move on to the next trainer ID. After doing that, we close and deallocate our cursor. To run our sample, we just use select as is from. Take note, DBO prefix is not used anymore. Okay, DBO that prefix is only used for scalar functions. It is not used for table valued function. After executing this one, okay, we will have this output. So there you have it, guys. That is our lesson for user-defined functions. Please try to execute the samples that I have included at the end of your lesson. All the codes are there, all the data are there. Kindly execute it on your own. Thank you.